crystalline solids are. In today's lecture, we will talk about liquid crystals. I think most of you have seen melting of ice. Ice converts directly from solid phase into liquid phase when liquefied. In fact, mostly solids, when heated, convert directly from solid phase to liquid phase. But there are also many known substances which have an intermediate phase between solids and liquids, which shows some properties of crystalline solid and some properties of liquids. For instance, cholesterol benzoate is a substance that has this intermediate phase. Cholesterol benzoate is a white colored crystalline solid below 145 degrees Celsius, but when we heat it above 145 degrees Celsius, it shows a cloudy white liquid phase from 145 degrees Celsius to 179 degrees Celsius, and above 179 degrees Celsius, it becomes clear liquid. Also, this process is reversible, means if we cool down the cholesterol benzoate below 179 degrees Celsius, then this intermediate phase reappears, and at 145 degrees Celsius again we get white crystalline solid of cholesterol benzoate. Let us now discuss this intermediate or say metaphase in more detail. As all of you know, solids are relatively rigid. By rigidity, we mean that relative position of any two constituent particles, atoms or molecules is fixed, and this is because of strong intermolecular forces among the atom or molecules of the solids. Therefore, solids have a fixed shape and volume. Moreover, in crystalline solid, atoms or molecules also show order in orientation and periodicity in position. In contrast, the liquid phase is a disordered state in which there is no fixed position of atom or molecules. Molecules have sufficient thermal or kinetic energy so that they can overcome intermolecular forces and hence be able to flow anywhere in the phase. Liquid crystal phase is an intermediate or metaphase, although not all substances show this phase, but there are thousands of known substances that may have this phase. In this phase, molecules have position like liquids and orientation like solids. Means molecule can flow like liquid as they do not have any fixed position, but they have a preferred direction of orientation of molecules. The molecules of liquid crystal usually tends to have polar or polarizing group. In most cases, the intermolecular interactions are due to the presence of these polar or polarizing groups. Intermolecular interaction may be strong dipole-dipole or dipole-induced dipole interactions or hydrogen bonds or combination of both. Aromatic rings, multiple bonds between carbon and nitrogen or oxygen are very common. Due to intermolecular interactions, molecules tends to orient in same direction and molecules are not able to tumble. Liquid crystals are anisotropic, means their properties depend on the direction in which they are viewed. In fact, anisotropic nature of liquid crystal is because their molecules are anisotropic themselves and rigid in the shape. Molecules of liquid crystals are also called mesogen. Liquid crystals can be named as per their mesogen. Structurally, molecule of liquid crystal can be linear. In that case, liquid crystals are called calamatic liquid crystals. Molecules can also be of disc shape. In that case, we call liquid crystal as discotic liquid crystals. The mesogen of liquid crystal can also be of banded structure or banana shaped structure. In that case, we call it as banana shaped liquid crystal. Or we can also have polymer liquid crystal with polymer mesogen. As I mentioned earlier, liquid crystals are crystals in the sense that their molecules have orientational order. But here the idea of positional order is a little bit flexible. Liquid crystals can also have some sort of positional order. This positional order can be changed by varying solvation structure or temperature or both. There may be more than a dozen of surfaces over a range of temperature for a given solvation structure. Liquid crystal molecules can orient themselves in one of the three ways. The first one is symmetric phase, which is low temperature phase. As the temperature rises, positional order decreases, and this may give rise to another phase called nematic phase. In both the phases, there is a single preferred direction of orientation for all molecules. The third phase is cholesteric phase, which is usually shown by banana-shaped molecules. Symmetric phase is a low temperature phase and usually shown by linear molecules. Symmetric means soap-like. You may have seen a liquid-like thing in your soap case at your home, which have some sort of fluidity but that try to stay together. Molecules in symmetric also have some positional order. Molecules are arranged in layer along with the orientational order, but if we see within a layer, then there is no positional order. Molecule can flow within a layer. Symmetric phase can also be subdivided into subphases. For instance, if the molecules are oriented along the normal of the layer, then it is called symmetric A phase, and if director makes some angle with the normal of layers, then it is called symmetric C phase. In the nematic phase, there is no positional order, but all the molecules are oriented in the same direction. This phase is a relatively high temperature phase. The third phase is a cholesteric phase or chiral nematic phase. This phase is mostly shown by banana-shaped molecules or molecules with a banded center. This phase is called cholesteric phase because it is usually shown by derivative of cholesterol. This phase is also shown by those liquid crystals which are obtained by mixing a chiral molecule with a nematic liquid crystal. Hence, these are also termed as nematic chiral liquid crystals. In this phase, molecules are oriented in a helical structure. Director vector turns slightly in each subsequent layer. An important parameter of cholesterol liquid crystals is pitch. This pitch is the distance along the axis between two molecules with parallel director vectors. Pitch can be changed by varying temperature, pressure, or by applying electric or magnetic field. Liquid crystals are anisotropic. Their properties depends on the direction in which they are viewed. The one way to modify the optical and electrical property is to alter the direction of director. The polar molecules of liquid crystal can interact with the electric field. This allows them to change their orientation slightly. A translucent nematic liquid crystal in a direction may become opaque in that direction when an electric field is applied and the molecules change their orientation. Likewise, the orientation can also be altered in some liquid crystal by varying temperature. A liquid crystal may reflect different wavelengths of light if molecular orientation changes. The liquid crystals have a wide range of commercial applications. They are used, for example, in the liquid crystal displays in digital watches, calculator and computers and video displays. We also see the effect of liquid crystals in nature. Jewel beetles changes color because of the light reflecting properties of the cells that make up their external skeletons. Thanks for watching. See you next time.